morning to all. Last class we discussed up to types of process. Okay, today again we have to discuss some terms: heat exchange, work, internal energy, and enthalpy. Right. First one, heat exchange. Heat exchange. Q. What is the heat exchange? Heat energy, whether supplied to the system or emission from the system. That means heat energy flows from system to surrounding or surrounding to system. Okay, here heat energy means the temperature difference. The temperature difference between system to surrounding. Heat exchange means, or heat energy means, the temperature difference between system to surrounding or surrounding to system. Okay, here mainly important science. If heat energy supplied to the system, heat energy supplied to the system, Q equal to positive. Q equal to positive. Next, if heat energy emission from the system or system to surrounding, if heat energy from system to surrounding, that means Q equal to negative. That means heat energy into the system means Q equal to positive. Heat energy release from the system to surrounding, that means out of the system means Q equal to negative. So these signs are very important. Definitions no one asking in the signs are very important. Next one, work. Okay. Already in physics you know about work. Okay, double equal to P del V in physics. So already learning in physics, work equal to force into displacement, again force equal to pressure into area. So you are not needed, that derivation not needed. But finally knowing double equal to P delta V, you know in physics. In chemistry, work equal to minus P del V. The pressure also external pressure. Pressure also external pressure. This is important. So in chemistry, okay, in chemistry, work equal to minus P del V. Here pressure we take it as a external pressure. Okay, physics double equal to positive P del V. Okay, while chemistry you reading our problems calculating, double equal to minus P delta V you should take. Okay, now next one, here very important. Signs are very important. Signs are very important. Conventions are very important. Conventions are signs. So chemistry completely opposite to the physics, right? Work done on the system is work done on the system double equal to positive. Okay. What done by the system means W equal to negative. In physics it is reverse summa. In physics it is reverse. Chemistry, work done on the system means double equal to positive. Work done by the system means double equal to negative. So while reading physics, reverse comma, that's why in exam whenever sums come physics and chemistry, physics reverse. So you remember carefully. Otherwise reverse you taking means wrong answer come. That's why chemistry means done on the system means positive, done by the system means negative. These are the conventions for work. Conventions for work. Right. Next one, internal energy. Internal energy. Internal energy. U. What is the internal energy? So internal energy we define as a sum of the energies associated with its atoms or molecules. Translation energy, rotated energy, electronic energy, vibration energy, nuclear energy, like that. So all energies, all these energies associated with its atoms or molecule, that is called internal energy. Okay. Internal energy is the extensive property and it has a state function Okay. Next, internal energy we cannot calculate or we cannot measure directly, exactly. Internal energy we cannot measure exactly, but change in internal energy we have to measure. That's why change in internal energy means del U. Del U means, so some books given E also, Y also correct. E also correct. Both symbols correct. New books given U, old books given E. So del U or del E equal to internal energy of final minus internal energy of initial. So internal energy we cannot measure exactly, but we can measure internal energy final minus initial. Understand now? Final minus initial we should calculate. Okay. For reaction, reactant gives rise product. So change in internal energy equal to internal energy of product minus internal energy of reactant. So change in internal energy equal to internal energy of product minus internal energy of reactant. Okay. Generally, internal energy can measured in bomb calorimeter. Generally, internal energy can measured in bomb calorimeter at constant volume. It can measured in bomb calorimeter at constant volume. Bomb calorimeter at constant volume. This is about the internal energy. Next one, enthalpy. 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 Right. the enthalpy. Enthalpy means the heat measured at constant pressure in system or process. Heat measured at constant pressure. Okay, so enthalpy, heat measured at constant pressure. So QP means heat measured at constant pressure. Okay now. So enthalpy represents by H. Enthalpy equal to sum of the internal energy and pressure and volume. Pressure and volume. That means enthalpy equal to internal energy plus pressure and volume. Okay. Then enthalpy also state function. It is also state function and extensive property. State function and extensive property. Enthalpy also we cannot measure exactly. Okay, enthalpy we cannot measure exactly. That's why we can measure only change in enthalpy del H. Del H means change in enthalpy. Okay, so we can measure only change in enthalpy. Change in enthalpy equal to enthalpy of final state minus enthalpy of initial state. Okay, then for a chemical reaction, reactant gives to product. So change in enthalpy equal to enthalpy of product minus enthalpy of reactant. So enthalpy of product minus enthalpy of reactant. This is about the enthalpy. Okay. Now very important one. Thermodynamics first law. Very important. Thermodynamics first law. Thermodynamics first law. Okay, definition not clear. Already know. He knows what is the definition. Energy neither created nor destroyed. Energy transferred from one body to another body, like the definitions given. Okay, we want only mathematical expression. Okay, what is the thermodynamic first law mathematical expression? Change in internal energy equal to heat energy Q plus W. This is the. Then physics Q minus W common in physics. Okay, in chemistry thermodynamic first law, change in internal energy equal to Q plus W. That means your work done by the system. Your W means work done on the system. W means work done on the system. Work done on the system. Okay, na? So your W means work done on the system. In physics, work done by the system come in physics. Okay, this is the thermodynamics first law, mathematical expression, very important formula. Then last class we discussed process. That process or we can applicable to thermodynamics first law. That's why first law in isothermal process. First law in isothermal process. First law in isothermal process. Isothermal process means what I say? Del T equal to 0 or temperature remains constant. Temperature equal to constant. In isothermal process, already given internal energy change equal to 0. In isothermal process, internal energy equal to 0. Now, thermodynamic first law del U equal to Q plus W. Here del U equal to 0 now. Del U equal to 0. That's why Q equal to minus W or W equal to minus Q. Both are same. W equal to minus Q. Okay, first law in isothermal process. That means heat to supply Q means a positive Q. Heat to supply to the system equal to work done by the system. Concept understand amma? So first law in isothermal process, if heat supply to the system means work done by the system come. If heat released from the system means work done on the system come. So please carefully understand amma. First law in isothermal process, if heat supplied to the system means work done by the system come. If heat released from the system means work done on the system come. Understand? So theoretical questions asking amma. They asking theoretical questions. That's why you should write these 2 points in your notes while watching video. So you should mention these 2 points in our notes. Okay. Next one. Isoporic process. First law in isoporic process. First law in isoporic process. Isoporic process means del V equal to 0. Volume remains constant. So thermodynamic first law, del U equal to Q plus W. W equal to minus P del V. Here del V equal to 0 means here in isoporic process del V equal to 0, automatically total work equal to 0. That's why del U equal to Q come. Del U equal to Q come. That means here meaning amma. Here Q positive na. Here Q positive. Work supplied to the system means internal energy also positive na. Here internal energy also positive sign. That's why work supplied to the system means internal energy increases. Work supplied to the system means internal energy increases. Work supplied to the system internal energy change increases. Internal energy change increases. That is the meaning. Next, first law in adiabatic process. First law in adiabatic process. First law in adiabatic process. Okay, adiabatic process means no heat change. It's isolated system. Q equal to 0. So thermodynamic first law, del U positive na. Work done on the system means internal energy change increases. Here W positive. So work done on the system equal to internal energy change increases. So theoretical questions asking about work done on the system. Work done on the system equal to internal energy change. Internal energy change increases. Internal energy change increases. Internal energy change increases. Okay, this is adiabatic process. Next one, cyclic process. First law in cyclic process. First law in cyclic process. What I say cyclic process means initial state to final state, again final state return to the initial state. In cyclic process, enthalpy internal change equal to 0, enthalpy change equal to 0, Gibbs energy change equal to 0, entropy change equal to 0, already given. So internal energy equal to 0. First law, del U equal to Q plus W. In cyclic process, internal energy change equal to 0. That's why Q equal to minus W or minus Q equal to W. Okay, if heat energy supplied to the system means work done by the system. If heat energy released from the system means work done on the system. Work done on the system. This is first law in cyclic process. Then first law in isobaric process. First law in isobaric process. Okay, isobaric process. Pressure remains constant or del P equal to 0. Okay. Del U equal to Q plus W. Here W equal to minus P del V. Listen. Here change of value. Pressure is normal pressure. Here not a change in pressure. Okay. Volume only change in value. Remember. So W equal to minus P del V. Now del U equal to Q plus minus P del V. Right. Q come to this side. QP. QP means heat exchange at constant pressure. QP means heat exchange at constant pressure. QP equal to del U plus P del V. Next. QP equal to del U means change in internal energy equal to final internal energy minus initial internal energy. U2 minus U1 plus P. Change in value means V2 minus V1. Okay, V2 minus V1. Next step. QP equal to U2 plus PV2 minus U1 plus PV1. So already we know enthalpy equal to U plus PV. Enthalpy equal to U plus PV. That's why QP equal to here U2 plus PV2 now. That means H2 minus U1 plus PV1 now. H1. H2 minus H1. Finally, heat capacity at constant pressure equal to H2 minus H1. That means change in enthalpy, then H. So, in isobaric process, at constant pressure heat capacity equal to change in enthalpy. This is the first law in isobaric process. You should remember, in isobaric process, heat capacity at constant pressure equal to change in enthalpy. Okay, this is about the isobaric process. Okay students, thank you very much.